Okay, so this one's a little bit different in that we already have everybody on one side of the equal sign. When we started off quadratics, guys, we talked about the idea of there being a step 0, which was get it all equal to 0. And that's not a bad strategy. When you're using solving by square root, because I only have a x squared term, this guy right here, notice there are no other x's in the problem. Just that one. What's what?
Is that get x all?
Get it all equal to 0.
Wait, so the first step would be to add 2 on both sides?
No. Remember, the order of operations say that the first thing you have to do is deal with addition, subtraction. Then you peels off. Back when we started with algebra in Unit 2, we started doing algebra equation problem solving.
Do the opposite.
Right, do the opposite, but you work from the outside of the problem to the inside. It's like peeling an onion. Each layer comes off until you get to the core. So that's what we're doing here. I'm going to start by dealing with the 80 first. Then I'm going to deal with the -2. Then I'm going to deal with this squared part. So when you track our steps, you can see step by step I'm peeling another layer to get to that x, the creamy x middle. The gooey chewy at the middle of the gobstopper.
Why didn't we do this stuff? Why didn't we do this?
You eat what you like, I'll eat what I like.
Why didn't we peel the onion on the first one?
Back up. For those, just to back up, look at the sequence of steps. First I dealt with the -10, which was the outermost layer of the left side of the equation. Then I dealt with the 4. Then I dealt with the square. I worked my way towards the x. So in this problem, I'm doing the same thing. I'm going to go ahead, peel off this 80 from both sides.
How do you know what side to start from?
The goal is to get the x squared by itself. So I do whatever I have to do to get this isolated. So I'm going to, if I look over here on the left side of the equation, there's nothing to do over there. There's no x's to try to get by themselves. So I don't need to do anything. But over here on the right, I can still do stuff. What's up?
Now, would you add 2 to both sides?
I'm not going to add 2 to both sides. But the 2 is what goes next. Rudy? I'm going to divide by that -2. Because there's an unsaid time sign there.
Mr. Ostman?
Yes?
Why do you cross out the x squared and then bring it back down? He highlighted it.
I highlighted it. That's highlighting.
There's no square root.
So wait, so do we divide by 80 or divide by 2?
Divide by -2. Because remember, this x squared is the one I'm trying to get, you know, by itself. That's the.
Why does it matter? Because you can divide by 82 and so on.
But if I divide both sides by 80, I'm not getting at this x. Dividing both.
Divide by the number that's
Yes.
smaller.
No, I divide by whatever number is next to the x.
Oh, okay.
So this now, negative divided by negative, rules of math tell me that's going to be
40.
positive or negative. Positive 40,
Is it a 40? How does it make it be squared?
x squared.
And there's no square root for 40.
Right. So if the question says, what's the exact answer? Let me write the last step out. Square root of both sides.
Wait, negative plus negative equals positive, right?
Positive times negative is negative. Negative times negative is
Yeah,
positive.
I know. So negative 80 divided by -2 equals positive 40.
Yes.
Oh.
That is my exact answer. Now, what you'll see 9 times out of 10, they'll ask you to come up with a decimal and round it to the nearest 10th or 100th. 10th is the first decimal place, 100th is the second. Calculator time. I take 40, push the square root button, and I get an answer of 6.3. I'm going to round it to the 100th. So, well, if I don't round it, I will be here forever writing it out. Because remember, the square root of a non-perfect square is irrational. It never ends.
So what'd you do to get 6.32?
Took my calculator, and I said 40, push the square root button, and the screen says this, 6.234553, and there's probably more that I can't see. So I'm going to round it to the 100th place, which means since 4 is smaller than 5, I round down. Square roots have positive and negative answers, and I'm done.
So we're going to need a test.
You are probably going to want a 5-function calculator to survive this because there will be problems that ask you to take the square root and reduce it. And unless you want to memorize all of the square roots for numbers 1 through 50.
Wait, how does the button look for the calculator that?
It looks just like the square root symbol.
Oh.
Just like that.
See, I don't have a calculator.
It might be a shift, so.
Yeah, you might have to shift. It might also be located above the button that says x squared. There might be right above it a square root button, so you have to push the shift button first. Take some time today while we're working in class. Review your calculator. Make sure you know how to make it do what you want it to do. And honestly, guys, $1 at the dollar store gets everything done you need to get done, and it's big enough that nobody can accidentally drop it in their pocket and walk off with it. You can also, for another $1, go to the hardware store, get 2 feet of steel chain, and they will happily attach it for you there. And at that point, if they're stealing your calculator, dude, let them have it.